Suppose a profit function is given by p of x equals negative x cubed plus 9x squared minus 15x minus 4. According to the graph, what is the ideal number of items to produce if you wish to maximize the profit? Well, if we do this question just by inspection of the graph alone, it appears that right about here, 5,000 items would be the place where the profit is maximized. Now, just to be sure that that's correct, though, we should do the calculus on it. So let's find dp over dx, which will be negative 3x squared plus 18x minus 15. Okay, we want to set that derivative equal to 0. And we can also divide by 3 on both sides. Actually, I'll divide by a negative 3. This will factor into x minus 5, x minus 1. So our solutions will be at x equals 1 comma 5, which we do see we have a minimum at x equals 1 and a maximum at x equals 5. So the maximum occurs at 5,000 units. Now it also says at which production levels will we break even? Now in order to break even, we need the revenue to equal the costs. Or another way of saying that is we need the profit to be 0. Now there are 2 locations at least where that happens. Right here and right here. Okay, now if we trace those down, we can see that this is where the profit is 0 and it's where the revenue equals the costs. It's called a break-even point. And there's another one over here. If I had to approximate it, I'd say maybe at x equals 2,600 and perhaps at x equals 6,600. We don't have functions for the revenue and the costs, so we can't solve it exactly that way. However, we could solve by setting the profit function equal to 0 and then using an online grapher. So I'll go to desmos.com and let's just type in this function that we were given for the profit. Okay, here's the function. Yeah, so we just want to click on the intercepts here. 2.577 and 6.656. All right, now we're asked to find the marginal profit. So for this, we actually already have it above. Marginal profit is the derivative with respect to number of units produced. And it's supposed to be the increase in profit for every additional unit that is made. Okay, now we'll find the marginal profit at x equals 3. We just have to plug a 3 into the derivative. Gives us 12. So this is $12,000 per 1,000 units, which is actually $12 per unit then. Okay. We'll find the marginal profit at x equals 5. That's actually going to be 0. And the marginal profit at x equals 6. Negative 15, which is negative $15 per unit. Okay, now we want to interpret what the marginal profit means here to the producer. So at an x of 3, our profit is here. It's not at its highest level. It's not negative, so they're not losing money, but they're not earning as much money as they could be. And we also notice here that the marginal profit is 12. Then look at this profit level here at an x of 5. That's the highest profit that we could possibly have, and there's a 0 marginal profit, which means if you increase your production by 1 unit, you're not expected to gain any profit. Then over here at 6, we have fairly high profit, but it's not the highest that it could be. And the marginal profit is negative 15, which means for each additional unit you produce, you're actually going to go down in profit. So the question is, if a marginal profit is positive, what should a manufacturer do? Well, positive means it's sloped up. So as the units that are produced increase, the profit increases too. So they would want to increase production. That's what the marginal profit tells you. For every additional unit you make, you're going to earn $12 more in profit. Who wouldn't want to do that? What if your marginal profit is negative? What should a manufacturer do? Well, for every additional unit they make, they're actually going to be going down in profit in that case. So it would actually be better to decrease production.